everyone, welcome back to my channel. I apologize if there's like this white noise in the beginning. It's from this mic I bought from Amazon. I don't know how to fix it, but it always creates some sort of white noise in the very beginning, and I hope it'll be gone at this point. So let's start. The question is, find if path exists in graph. It's an easy question, and the question says that if there is a bidirectional graph with n vertices, where each vertex is labeled from 0 to n-1 inclusive, the edges in the graph are represented as 2D integer array edges, where each edge equals u and v, denotes a bidirectional edge between u and v. Every vertex pair is connected by at most one edge, and no vertex has an edge to itself. You want to determine if there's a valid path that exists from vertex start to vertex end. Given edges and integers n, start, end, return true if there's a valid path from start to end, or false otherwise. So let's look at example 1. N equals 3, representing these 3 vertices, and then the edges 0 to 1 is connected, 1 to 2 is connected, and 2 to 0 is connected. Start is 0 and end is 2. And as we can see, it's connected on this graph, and that's why it returns true. It can go this way, or it can go this way, right? Let's look at the second example. N equals 6. So there are a total of 6 vertices here. Edges equals 0, 1, 0, 2, and then 3, 5, and then 5, 4, and then 4, 3. Start equals 0 and n equals 5. As we can see, they're not connected, so we should return false. There is no path from vertex 0 to vertex 5. So immediately, we can tell, like, there's multiple solutions to this. We can solve it using DFS, BFS, or union find. Previously in my channel, I've been solving graph questions using union find a lot, so I just want to talk about a union find solution to this, but today we're going to solve this using DFS. So the union find solution, if you're familiar with the union find algorithm, it'll be very simple. Basically, you just write the union find algorithm, then you span your graph with all these edges. After you've done that, you can write a connected function within the union find to see if two nodes belong to the same component, or if they have the same absolute root. And then we just return true if they're both, like, start and end is both part of the same absolute root, and return false otherwise. But today we're just going to do a simple DFS solution. So for DFS, we'll be storing our edges in a adjacency list. Since it's bidirectional, we're going to store it back and forth, and I'm going to use from collections import default. I'm going to use a default dictionary and to create my adjacency list. It's going to be a dictionary of lists, and let's span it right now. So for node 1, node 2, and edges, we can do adjacency list, node 1 dot append node 2, and then adjacency list, node 2 dot append node 1, and this is how we span our adjacency list. Since it's bidirectional, it's back and forth. It doesn't have a direction, that's why we do it back and forth. And yeah, we can start writing our DFS. So DFS, we're just going to take a node. Before we do that, I want to create a visited set so we don't go into loops. And then we can write the base case. DFS basically uses stacks, right? Because it's a stack-based algorithm, but usually people write it in a recursive way, so it's like a recursive call stack. And with recursion, we have to have like a base case. So what's our base case here? If our node will be treated as the start node. So if node equals n, that means there's a path between start to end. We can just automatically return true. And then if node not invisited, then we can do visit.add node, and then we can like check its neighbors, right? So for neighbor and adjacency list node, and we can recursively run this. Let's do result equals DFS neighbor, and if result, we can just return true. So this means for each of the, after we span this adjacency list, for each of the neighbor that's connected to node 1, we check all its neighbors and we recursively check it, right? And then if it goes to this point, it will return true, and this true will go to the result. And if the result at any time returns true, then we know it's true. So it's pretty simple. So we can just return the DFS with our start node, and then if it returns true, it will also return true here. Let me know if you have any questions, and thank you for watching.